Thank you for the lovely introduction. So, yeah, my name is Koenig. I'm a software engineer from Wellington in New Zealand. And to start this off, I want to basically talk about a quick story about an interesting sounding app. So let's imagine we're going on some amazing adventure, right? And adventure is not for the faint-hearted. It will get you off your couch, and basically you will go outside, do some stuff, hang out with friends, walk around your neighborhood, and do some really amazing things outdoor. And as part of that adventure, you discover a world of virtual characters roaming the streets. And some of them you can catch, some others you can train, or you will fight some of them. And that sounds like a fun game, right? The problem is, what would happen if I said, all you need to do to participate in that game is to spend £50 to buy the app in the App Store? Usually the reaction would be something like this, right? And it's because we have, as humans, a huge thing about risk aversion. We avoid risk. And we don't want to spend £50 to get whatever cool experience that might be. Research shows actually that if an app user wants to get a solution for a certain problem, they will pretty much always opt for the free alternative before they spend even 99 cents upfront in an app store. And if you have an amazing app, but you want to sell it upfront, and it's your creation and your superannuation plan potentially, then you have a problem. So the app I was talking about is obviously Pokemon Go. So I'm that person that still plays Pokemon Go, by the way. Hi. So to run this whole infrastructure for Pokemon Go, they have a huge pool of servers, they have a whole bunch of developers continuously working on the app, and there is a huge pool of licensing money for Pokemon, basically, that goes to Nintendo. So how would Niantic, the company that runs Pokemon Go, make money with the game? And the short answer is they do in-app payments, right? They sell you stuff that you can buy through the app after you downloaded the free game and kind of got hooked into it already. There's no initial cost, but what they do is basically they sell you a virtual in-game currency called Pokecoins, and they sell that to you for real money. And then you can use these Pokecoins to trade them into other items in the game. Essentially, what it means is you trade real money against faster game process. That's a quite common model in games. So stuff you can buy is, for example, 2,500 Pokecoins for £20, or even up to 14,000 for £100. And people buy those packages. I mean, you think like, whoa, this is a lot of money for some virtual currency, but that stuff sells actually, right? And that's just 3 of the products they have available. And you can see it has a quite steep pricing curve in some instances. So what that proves is people are willing to pay money if your app is compelling and interesting enough. And they are easier willing to part with money when you do it after they have been using the app. Another quick statistic, that's basically showing how long it takes or how long it took for certain apps to reach $2 billion revenue through in-app billing. 2 billion, that's a mind-blowing figure when you think about that, right? And Pokemon Go took 811 days. That's roughly 2 years and a bit since the launch of the game, and they made $2 billion US, and that's huge, right? One of the tools they used for Android for that would be Google's in-app billing. And what we're going to do for the next 40 minutes or so is to have a deeper look at the library that helps you to interact with Google in-app billing. So essentially, there are some things to talk about. We're going to learn about some of the fundamentals of the in-app billing service with Google Play Billing on top. And we'll talk about stuff like the difference between a product and a subscription and how you manage all those things. There are tons of pitfalls as well that you could easily run into, and it seems to me that not many people are talking about all those pitfalls. So we're going to have a look at some of the problems and some of what happens behind the scenes inside of the library. And finally, I'll show you towards the end some real-world concerns about integrating your app and in-app billing with like your backend and real-world solutions, because what you get out of the official documentation seems to not mention all the details on that either. So to start off, let's briefly talk about the Google Play in-app billing service. Right? That's an underlying system service that conceptually allows you to sell digital content on Android. And when we talk about digital content, that might be virtual products, like a download, a graphic, an ebook, sound, whatever you can imagine, or it might be in-app currencies, like for example in Pokemon Go, where you have the opportunity to buy coins and then do something else with that currency. The in-app billing is conceptually available in Android since about 2012. In 2017, Google added a layer on top of that called the Google Play Billing Library. It's also known as Billing Client, quite commonly. That was released in 2017 as like a developer preview and is currently at version 2.0.3 since a few weeks ago. What is kind of interesting is that Google saw the need to come up with a solution for in-app billing that sits on top of the actual service. And I don't know who used in-app billing before that library came out, but we usually had to deal with a lot of stuff like inter-process communication or use that AIDL format to communicate with that service, and that wasn't really nice. So now we've got the Google Play Billing Library. And from like a 30,000 foot point of view, the library is basically an abstraction layer on top of the service. So if we look at the overall architecture of that whole thing, you basically start with your client. And when we communicate with billing on our client, it always involves a server connection to something. You can't do it only on the device. So on the client, we have the app, and Google Play Billing Library sits somewhere in your app, basically. And what might happen is your user initiates a transaction. So when your user does anything with the Google Play Billing Library, it usually ends up communicating with a part of the Google Play app to then deal with the Google Play infrastructure that Google provides, basically. Because all your payments and all your payment processing run through Google Play, even though it's an in-app purchase. So from the Google Play application on your phone, there's a communication going on to the Google Play server infrastructure. But in reality, what you also will need is a communication that talks to your backend application that then talks to another API on Google's end that is called the Google Play Developer API. And the typical use case that we're going to cover a bit later is payment verification, for example, or getting notifications from the Google Play infrastructure that a user has canceled a subscription, or that they want to change the terms and conditions of the subscription, like changing from a 12-month to a 3-month subscription, or similar things. The current version of the billing library is 2.03, as I said before. And it has gone through quite a few iterations over the last few years. Particularly version 1.0 and version 1.1 were reasonably problematic when it came to certain functionalities. And 1.2 was a really stable release, and 2.0 now brings a whole bunch of new things, basically. What you can do with the library is, in general, things like retrieve products or subscriptions or pricing information from the Google Play infrastructure. You can check for your users' previous purchases in your app. That might be kind of useful to determine what you want to show to the user and what you don't want to show to the user anymore. You can do things like buy and consume products, and we'll talk about consumption in a few minutes. You can acknowledge purchases, or you can start subscriptions. And starting a subscription basically means like you are triggering a purchase that is recurring from a business point of view model. On the back end, it might not be as obvious why you need that. And I said before, the common use case is verification. Because when you think about what happens is, your user purchases something, your app communicates with the Google Play infrastructure, and you get something back from the Google Play infrastructure, like a purchase token or verification code. But I mean, we all know that apps can be hacked and deobfuscated, and people tinker with stuff. So you want to make sure that whatever you get back from the Google infrastructure is really valid before you enable content in your app. Because otherwise, people could quite simply hack your app, fake a successful verification on the device, and you would potentially enable content that is already in your app for free, and you don't want that. Other use cases are the notifications you can get for subscription changes, and this whole Google Play Developer API is a REST API. And it's not rocket science to implement that, but it's not quite trivial either, because what I found when I was working with that API is the OAuth flow that Google requires for your backend to communicate with their backend can be sometimes a bit tricky and fiddly. Let's have a look at some code. Here we see the basic setup for Google Play billing library in your project. So we've got a dependency. We need to add the billing permission in our app. And then the setup itself is pretty much creating an instance of billing client and run a builder against that with certain functions. Internally, behind the scenes, if you look at the library, there's some interesting stuff going on. So this is actually the billing client builds function from the library. And what you can see is it checks for a few weird cases. So if you don't provide a context or a listener, or if a thing called pending purchases are not enabled, it will basically flat out say, no, I'm not dealing with you at this stage. And what it then does is it returns a new billing client implementation with all the stuff you've passed in, or haven't passed in some instances. And the billing client implementation is really where all the magic happens pretty much. Billing client is just an abstract class. Looking at the overall library, this is kind of the class diagram. And it's not huge when you look at it, so it's not a massive library, but there are 3 quite noticeable clusters of classes and interfaces. And we'll have a quick look at those 3 clusters. The first one is what I called billing client and friends. So basically, billing client is the core abstract class, and we've got a billing client implementation on the left-hand side. And then we've got a whole bunch of internal inner classes and inner interfaces, and they're usually only there to help manage the state. So you have things for like consent age, if something is directed towards children, for example. You've got a class called SKU type, and you've got a few other things like features and billing response codes that can come back from the server infrastructure. What I found when I was actually starting to work with Google Play Billing Library and trailed through their code, that some of the code in the comments in the library are really useful to look at. So for example, this is from a bit of code that deals with COPPA. COPPA is a Children Protection Act from the US mainly, which is supported in Google Play Billing Library. But the interesting thing is, when you look at actually the documentation, it says at some point here, note, it may take some time for this designation to be fully implemented in the applicable Google services. So you're kind of like, you can actually use it already and set it all up, but they don't guarantee that all the other Google infrastructure correctly deals with that information that you provide. So it's more of a, yeah, please do that, and we'll get round to do it on our end at some point, which is fair enough. The second big cluster of classes is centered around native callbacks. And they are used mainly to communicate between the in-app billing service, that is our system service, and the Google Play Billing Library on top of that. And that usually happens via JNI calls using the Java native interface. So we've got a whole bunch of interfaces here for various scenarios, like acknowledging a purchase, or a price change confirmation, and they all come through the billing client native callback system. And the third cluster are classes that I would generally put under a bunch of management and helper classes. Usually, they deal with products, SKUs, and parameters you would need to process payment transactions for purchases and subscriptions. And quite a few of them are just value objects that push data back and forth. So let's move further into the process of using the library. Here we see our existing billing client instance, and we're starting a connection. And what basically happens is we're overriding two functions, a onBilling setup finished and onBilling service disconnected. And obviously in the onBilling setup finished, that's where you are reacting on the service being available for use. So the start connection is pretty much triggering that whole connectivity to the Google Play backend. Internally, in the library, when you run start connection, and that's a quite full-on slide, I'm sorry for that, but basically in a nutshell, it creates a binding intent to the in-app billing service. And that happens basically up there at the top, and then a bit further down where we are basically doing Boolean connection result bind service. Around that, it's doing a whole bunch of checks again, right? So that is one of the core ideas of the Google Play billing library from my point of view. It's doing quite simple things when you think about it. It takes care of the communication with the system service, that we don't have to do it ourselves, and it takes care of providing a whole lot of checks and balances around that, that would, if we always had to do that ourselves, be really annoying. And the example that we're seeing here is also another snippet from the library, which points out quite nicely that the in-app billing service over time has evolved quite well. So depending on the in-app billing service version that we have on our devices, certain features might or might not be supported. And that can be problematic, right? Because you might want to use subscriptions in your app, but if you don't check if the in-app billing service on the device that is available even supports subscriptions, you will eventually end up with an application not responding or some other crash, basically. And having these attributes here and particular functions to check against them available makes your life as an app developer much easier, because you can say, like, are subscriptions supported, yes or no? And it will eventually fall back to one of these flags here internally. But you have those helper functions around that. So let's have a look at some of the potential problematic points with the setup process. So the first thing to note is there is this interface, that listener interface that we are setting up when we set up the library. That's an interface called Purchases Update Listener. It basically requires you to implement one function, and that function is called onPurchasesUpdated. And that method will be called whenever something happens to the purchases for that user in the current app. And there's an interesting quirk around that. That callback happens across all your devices, or all the users' devices. So just recently I was testing something, had like an app open on the same payment screen on like 2 or 3 devices. And I was doing something on the phone, basically testing a purchase. And then all of a sudden, out of the corner of my eye, I saw like my tablet on the desk doing something while I was triggering a purchase. I was like, wow, that's weird. And then I realized basically that I hadn't properly coded for the scenario of onPurchasesUpdated, obviously being called on all devices or triggered on all devices that are on the payment screen right now. And the problem with that was I hadn't catered for a scenario that that method would be called without actually a purchase happening on a certain device, and that caused the issue. That was a good thing that I found that problem quite early in the whole process. The other thing that is really important is you want to make sure you override onBilling service disconnect and do something useful in there. Because otherwise you will eventually end up with weird errors in really crazy scenarios. For example, while Google Play, the app, or Play services are updated and the user is doing something. So you want to really make sure that when, for whatever reason, your billing service goes down, you make sure that your app deals with that correctly. Let's talk about products and subscriptions for a bit. So they are quite interesting as such. When we have a look at some general thoughts around them, everything that happens with in-app purchases from a product point of view is managed in the Google Play console. So in the same place where you manage your product listing for Google Play. Quite obvious, I think, an app can have multiple products. So you can have one product or 10 or 100, and you can have as many subscriptions as you like. I'm pretty sure there is an upper limit, but for a practical purpose, you can do whatever you want there. And the other third bit, when you set up products or subscriptions, it can quite easily become a bit of a hassle when you deal with international pricing. In particular, if you want to go away from the standard pricing. So for example, I set up an app in New Zealand dollars for like 99 cents, let's say. What would happen in the Play console is Google creates prices for all the other countries that look nice. It might be 59 p in the UK, or it might be, 49 euro cents or something like that. Pretty much always with a 9 at the end, that it looks kind of pretty for a consumer. It also takes VAT into consideration. So what you find in the Eurozone, for example, quite often is you set up a price for one country, Germany, for example, €1.99, but Austria is €2.09. You think like, oh, that's weird, it's the same currency, but it is because the VAT rates are different, and Google Play console takes that into consideration as well. And you can go into all the default prices conversions and modify it manually, but it can take quite a while to do that because you're dealing with like 120 countries or something like that. And if you have 30 different apps, for example, then you have that multiplied. There's a feature called pricing templates, and if you are in a situation where you need to deal with many apps and different prices, that's usually the way to go. Specifically on the product side, we have a thing that is called one-time or managed products. And the core characteristic is that they represent a single non-recurring charge to your payment method. So you buy it once, and it doesn't repeat automatically. There's another thing in the product category that is called rewarded product. And they are quite new. And what they are is basically a free product that a user can get for watching a video delivered through AdMob, like a video ad, essentially. It's very important to realize that if you use this product type, it has implications on your app and what you need to disclose in Google Play, because all of a sudden, your app is using AdMob behind the scenes. And that can be tricky if you don't disclose that properly for certain categorization of your ads, of your app. The technical type of all these products in the library is called in-app. On the subscription side of things, we have basically a very similar scenario. It's an in-app product, but the difference is it has recurring billing. And the recurring billing can occur weekly, or monthly, 1, 3, or 6 months, or annually. And again, one little thing people sometimes stumble over is this is annually, it's not 12 monthly. So it's literally from like the 1st of Jan to the 1st of Jan, and not what 12 months would be necessarily. There's a subtle difference in calculating that. There are also some features like free trials, introductory pricing, and particularly the free trials seem to take off quite nicely. That was added just a year ago, maybe, but I see a lot of apps popping up using that feature. One other thing to be aware, though, is that depending on your system architecture, you might find that it's necessary to implement notifications for free trials running out. Because what you want to do is, after the free trial is finished in Google Play, you want to stop your users' access to whatever they purchased in some way. And finally, since Google Play Billing Library 1.2, there's also support for a thing called a pricing change for a subscription. And believe it or not, previous to 1.2, that wasn't possible. So you would launch a subscription product, and your only way to change the price would be to create a new subscription product, call it like Magazine 6 monthly version 2 with the new price, and then pretty much make sure that your users only see the new product from then on and not the old existing product. Now you can trigger a pricing change, and what that will do is it will pop up like a little dialogue to the user and saying, hey, this subscription will change price next time it rolls over. Do you want to agree, or do you want to basically cancel it at that stage? And the type for these kind of products is subs, is a technical type in the library. So let's have a look what happens when you're trying to retrieve a list of products. So in this case here, we have a SKU list. We add 2 SKU numbers, like product IDs, SKU1, SKU2. We wrap that whole thing in a parameter object, and then run a function called query SKU details async. So the whole library is asynchronously. Interestingly enough, when you look at this code at the top particularly, you might find it weird that I pass in the SKUs that I want to get details of. And from a general e-commerce point of view, that's really bizarre. Non-online shop solution I know would do it that way. Any other platform pretty much has a function that says, give me all my SKUs, or give me a list of all my products. That's not how Google Play Billing works. You have to pretty much know the product IDs you want to retrieve the details of to render in your UI. And that raises a question, like, where do you store that stuff, and how do you store that stuff? You could hard code that in your app, which is probably not the best idea, because it means if you want to launch a new product, you have to release a new version of the app. Or you hold them somewhere on your server that you basically go off to your own backend and say, give me a list of all my SKUs I'm currently selling, and then you run through this process. And that's usually what people do. Here's an example of looking at the purchase history. And what you can see quite often in the library is it deals with futures. So here, we basically launch an asynchronous call in a future that goes to a function query purchases internal. And that pattern is quite common. Eventually, after you trail down the whole call stack, you find query purchase history internal. And what you can see there is the core bit of that function is you go back to the service, to your in-app billing system service, and you call get purchase history. So again, for that use case, we are looking at the Google Play Billing Library, a very nice and posh and decently done wrapper around the system service that you don't have to do it yourself. The other thing that I found quite interesting here is it runs this whole code in a do-while loop, because it actually deals in a very nice way with the continuation token for you. That's kind of a problem with the in-app billing service sometimes, that you get lots of results, potentially, and then it gives you a token for the next batch of results. And the Google Play Billing Library abstracts that away and basically builds one list and gives you the whole list in one go. So the purchase flow, after we've set everything up and we know what we want to show. So as said before, Google Play Billing Library uses the Google Play app to do all of that, or most of that. And what you find is that depending on the Android version people run, sometimes you get different results or different looking results. In general, it is a very good idea to do billing client is feature supported, and you can pass in a whole list of features to check if certain things are available in your version of Android and the Play library in the first place. To actually launch the billing flow, we're building a billing flow parameter object first with the SKU details we want to buy. And then we just say billing client, launch billing flow with that parameter object being passed in. So that's kind of the things we have to do as developers. And what it will look like on an older device, for example, is kind of a dialog rendering on top of your activity. And you basically go through kind of a flow where you can use password or fingerprint or use choose your payment method. And on newer devices, it will look like more like this, where it comes up from the bottom, basically, as a little overlay, which is arguably the prettier option to do. But you don't have much influence over that. You'll find that that pretty much depends on the device, and like I said, the Android and Google Play libraries on your user's phone. Inside of the purchase flow, we see a very common pattern again, execute async. And in this case, we do mService, which is our in-app billing service, and we call get by intent on that billing service. Again, this case, once more, a really nice, pretty wrapper around the in-app billing service that we're dealing with. That takes us to some examples. So Google has a repository with samples, and some of them are problematic, and some others are really good. I wanted initially to dive deeper into those samples, but like in 45 minutes, you can do only that much. So I leave it explaining some of the samples and their problems. So the classy taxi sample, the top one, is reasonably new, but it's only for subscriptions. And it requires you to spin up a Node.js server to simulate a backend, basically. But it works, and it's kind of up to scratch with what the library is at. Trivial Drive, you can pretty much ignore. That has nothing to do with Google Play billing. Trivia Drive version 2 is using Google Play billing, but not a modern version, like an ancient version of the library. And the only one I would truly recommend you look at if you want to get an example of a good architecture and how to use the library is the Trivial Drive Kotlin. And basically what that does is it's using the repository pattern, it's using MVVM, and it is built in a really nice way that you can even take some of the classes, more or less, and move them over into your own app, if you want to do MVVM and repository pattern at least, and just populate it with your own products, which is quite straightforward to do when you go through the documentation. And the nice thing about that approach is it is another really well done abstraction layer on top of the Google Play billing library, because all of a sudden you have your products in your app, and they are managed in a nice way, and the app only talks to the Google Play billing service in certain conditions. So it basically tries to hold a lot of stuff locally inside of your app. Let's talk about integration. So far we've seen a basic flow through a purchase subscription scenario. But usually you need some further backend integration with your own features or some API. Additionally to that, commonly apps integrate with backends, right? I mean, if you have an app that is only an app, never talking to your own systems, that's quite unusual these days. So let's have a look at verification of a purchase. So when a purchase was successful, you get a purchase token from the library. And with that purchase token, you can do one of two things, or both. You can verify on the backend, or you verify in the app. So you get a whole JSON package back from the Google Play billing library that has like a signature and a token, and you can use some cryptographic functionality in your app to verify that. Obviously, that can be hacked if people want to. So the recommendation is go back to the backend using the Google Play Developer API and then verify it on their backend so that you know Google has received the payment from the user for this particular token. Ideally, you do both in a practical sense. The place where you would check the signature inside of the app is a function, again, called onPurchases_update. So when you have something happen with the purchases in the Google Play infrastructure, that's the point in time when you want to verify the purchase. And on the backend with the Google Play Developer API. It's a call to the REST API, but you don't do that call from the app. You call your own backend from the app, and then your backend communicates with the Google Play Developer API. The next scenario is consuming purchases. So if you have a product, you can normally only buy that product once per Google Play account, and that can cause issues, right? Like if I want to buy 1,000 Poké Coins in Pokemon Go, then I might want to buy another 1,000 Poké Coins in 2 weeks if I'm a really heavy user of the game. So there needs to be a way how we can kind of get rid of an existing purchase. And that's what's consuming a purchase basically is. So you say, I've purchased something, and either automatically on purchase or after the user confirms that purchase in some way, you say, now the user has consumed that purchase. And it might be that your 1,000 coins have been moved into the user's virtual wallet or something like that. And after the consumption, the user can buy exactly the same product again. So in Google Play, it's basically being reset for you. The way how to do that is through a function called consume async in the billing client library. And that's cool. You get a callback on consume response in a listener, and that's all fine. The reality, though, is there are problems. Because sometimes what happens is you do all the consume async, and you do all the callbacks and handle all that stuff, but then you do a query purchases or a query purchase async history or something like that, and it still shows up. And it's like, yeah, that's a bit bad, really, because now I can't sell that again to the user right now. And usually what it seems to be is caching issues and weird edge cases. So caching issues can occur sometimes on the API side when the communication with the Google Play infrastructure happens. Or weird edge cases could be your app crashes or Play service library crashes in exactly that moment when something was happening and the call hasn't gone through, and there are tons of potential problems that could occur. So the better way to do that is you use the server API, again, Google Play Developer API on the backend, and you check if a product has really been consumed or not. Acknowledging a purchase is a quite new thing. So if we have a consumable, then it gets automatically acknowledged when consume async is being called. If you have a non-consumable product, then there is a specific function called acknowledge purchase that allows you to acknowledge the purchase. And that whole concept of acknowledging a purchase itself is a bit weird because it essentially has to happen within 3 days after the purchase. Otherwise, if you don't do that, they get the money refunded. And like I said, that's a very new thing in Google Play Billing Library 2.0. And my feeling is the use case will be something like a mix of virtual and real-world payments that you could, for example, go into a shop, buy a card, like a gift card with a voucher for an app, and then use that gift card to do an in-app purchase. And then that obviously has to be acknowledged in some way because the Google Play library and the Google Play Store wouldn't know anything about that gift card voucher at this stage. Quick mention about the real-time notifications. If you want to be notified in subscription land of a subscription being canceled or changed, you need to implement these. And basically how it works is you have your Google Play Developer API, and that consumes with a Google Cloud push pub sub setup, and then that communicates with your backend application. That's the common pattern. There are tons of other things you could do, but that's the easiest way to get started without spending lots of time on setting up like a real-time push infrastructure yourself. And that takes us to the last topic, which is testing. So one thing I hope is all the examples that we've seen so far basically take you away from that implied rhetoric of you don't need to build a backend. Because in reality, you need to build your own backend for a lot of these things if you want to do them right. So that's one thing, or the one thing I want everyone to take away. You most likely will need your own backend if you want to do in-app billing properly. When it comes to testing, previously it was reasonably easy to test, right? You could basically set up a few draft products in Google Play and then test your app against your products that haven't been published yet. That's not possible anymore. You can use static product IDs, SKUs, to test trigger certain responses in Google Play. The problem with that is that only works for products, not for subscriptions for some reason. And that leaves us with the last way of testing, which is do a published build to an internal channel, like the Google internal testing or an alpha channel or something like that, and set up the proper testing scenario. So downside is you have to tweak user accounts sometimes a little bit, make sure user accounts for testing are not user accounts set up in devices, etc., etc. It only works on physical devices, and you have to set up what's called licensed testers in your Google Play account, which is basically just a Gmail account. But the problem is that licensed tester stuff can only be set up by the account owner and not by you as a developer usually. So you have to interact with whoever runs the Google Play account in your organization. The good thing is with testing it that way, and if you want to test subscriptions, you don't have to wait a week or a month for the subscription to roll over. So in test mode, they roll over after 5 to 30 minutes. So that's kind of handy. And if you want to make your life even nicer, then you use a library on top of that. There is an excellent library called BillingX on GitHub. And it's an extension library in Kotlin that you can leverage to do fake purchases in debug mode in your app. So you don't have to necessarily fiddle around with credit cards or Google Play accounts. And it's really lovely for the initial steps of your app build and to do some testing before the app is even ready to go into the Google Play Store for an internal channel. The way how to implement it is basically just a dependency for debug and release. So for debug, you would refer to BillingX. For release, you would refer to the official billing client. And then build something like a billing client factory. And you have a factory for debug that returns the debug billing client, which is BillingX. And for release, you have a function that returns the actual billing client. And that basically makes sure that for each build type, you get exactly what you want. There's another library which I just briefly want to mention that is called Register from a team at the New York Times. They have built kind of a mock application that acts as a backend server on your device, which is really cool because it allows you to set response codes for all sorts of purchases. The problem with that is it doesn't support Google Play Billing Library properly yet. It works with the billing service and AIDL and all that kind of stuff, but not with the with the Google Play Billing Library and the billing client. Some final thoughts. So during the last 40 minutes or something like that, we've talked a lot about the technical aspects of in-app billing and how to implement it. So we covered some strategies, how you would use it, and some problematic parts, what you want to avoid potentially, or the facts that you need to add a backend to your system to do it properly. An interesting thing, an important thing that I haven't really covered is why would you want to do that in the first place? And why do we do what we do? We obviously want to make money with apps, right? But also another part of why we are in this industry is usually we want to do something cool and improve our users and customers' lives in some way, right? And in-app billing can, funny enough, contribute to that. I strongly believe that if you use it correctly and in a nice way, it removes a lot of the user's fear of spending large amounts of money for your app or small amounts of money for your app, depending on what you charge. It removes risk on their end. And at the same time, it can be really rewarding for you as an app developer because you can quite easily give your users something to play with and be interested in before you start charging them. The problem is, in-app billing gets a really bad reputation currently. And that's because it's very easy to abuse. So lots of companies, build addiction-triggering mechanisms within app billing, in games with loot boxes, for example, or to lure kids into spending huge amounts of money on virtual products that no one needs, and usually through their parents' credit cards. But at the same time, you shouldn't have to feel bad for making money with your apps, but always do it in a way that it's beneficial for you and your users. And I think if you manage to do that, then you make the world and the app ecosystem a little bit better, just a tiny bit, but we're getting away from this impression that anything that has to do with in-app billing and charging money and popping up things like, do you want to buy this and that, is dodgy. It doesn't have to be. Thanks a lot for attending and listening. Here are my contact details. The slides will go up on Speaker Deck like in half an hour or something like that in my Speaker Deck account. And the slides also contain a bunch of resources and links to interesting stuff. Cool. If you have any questions, see me maybe either here quickly or we go outside if the next person rocks up.